Good morning, students. I want to welcome you to your first Edpuzzle for the class. Your first learning Edpuzzle, the first time that I'm going to be teaching you. And so we're going to do a lot of these in the comments today for the assignment. If you have any questions or if there's something that's not making sense to you, you're having trouble with something, please make sure you're letting me know so that we can get things set up and working really well for your learning style. So we're starting today with chapter 1, an introduction to chemistry. And you'll notice in your book, this is your textbook right here. And you'll notice that in your book, there are quite a few useful pieces of information. Obviously, I'm holding the teacher copy of the book. But one of the things that you'll notice is in the chapter opener, there will always be this big idea. The big idea revolves around this idea that there are certain things we must learn in chemistry. And in chapter 1, the big thing that we are trying to learn is that chemistry is the central science. It connects to physics, it connects to biology, it connects all of science together, from medications to, ecology and plastics. All of those things are connected by what are those materials made of, which is what chemistry is. So in this chapter, we're going to be really trying to focus on this idea that chemistry applies to all sorts of your lives. The intention here is to get buy-in. No matter what you're interested in, and one of the questions for today is going to be, what are you interested in? And actually, let's start with that. So the Edpuzzle is going to go ahead and stop in just a moment, and it's going to ask you a question of what are you interested in? And I'm talking about you as a person. What are a few things that you like to study or read about or listen to? What are you interested in? Write them down, put them in the comments or put them in the Edpuzzle question so that I can start to tailor this class to meet your needs and your interests. So we're going to go ahead and stop. Great. Now that you guys have answered that, we're going to talk about what chemistry is. What is chemistry? So by definition, chemistry is the study of the composition, structure, and properties of matter and the changes that it undergoes. So in the first half of this semester, we're going to be learning about the composition, the structure, and the properties of matter. How are atoms arranged? How are atoms arranged within the atom? How can they bond to one another? How does matter get arranged? What even is matter? And then we'll spend some time talking about the changes that it undergoes. How does one type of matter become something else? When you toast a marshmallow, when you cook chicken, when you use your rollerblades or your roller skates and the wheels wear down, what's happening? Okay, when your bike gets rusty, what's happening? Those are the kinds of questions we're going to be looking at in the second part of the semester. So chemistry answers questions like, what is it made of? And also, what happens if you mix it with something else? So in this little picture down here, these are all different types of chemistry, right? We can study the atom, we can study solutions, we can look at organic molecules and interactions, we can distill one thing from something else, we can turn this yellow thing into this red thing. We can do all sorts of different things within chemistry. We can make new things, we can break things down, we can just understand what they're made of. And so those are all things that we're going to be going through in this semester of chemistry. So we break chemistry into 6 main branches, and I have like a little infographic here that I borrowed to explain the different types of chemistry. So we're going to go around the circle. Okay, organic chemistry here is the study of carbon and carbon-containing compounds. So things that are organic. There are more than 6 million organic compounds. Almost everything we encounter is organic. Often you'll hear organic used as a synonym for healthy or unprocessed. And so I always ask my students, if you go into the grocery store and you see organic apples and not organic apples, what's the difference? Okay, what are they made of something different? Is there something different about the composition? And hopefully organic items have been in our grocery stores long enough now that hopefully you know that that means that they are treated with pesticides that are organic. So they're not treated with the harshest pesticides. That makes organic produce more expensive because more of it gets ruined. When you use the really harsh pesticides, you are able to get a bigger crop. That's why we started using them in the first place. But then time has shown that perhaps those pesticides are dangerous to our bodies. So then we don't want food that was treated with them. So organic produce does not change whether or not the apple is made of carbon. It changes how the apple was treated while it was being grown and harvested and packaged. And so organic in the grocery store means something very different than organic in chemistry. In chemistry, all apples are organic. They're all made of carbon-containing compounds. In organic chemistry is the study of all compounds that were not covered by organic chemistry, things that do not contain a carbon-hydrogen bond. So making microchips for computers or mining metals to recover metals, those are things that would be covered in an inorganic chemistry study. Physical chemistry is over here. Physical chemistry is interpreting chemistry in terms of using some principles of physics. So when we said chemistry is the central science, right? So as chemistry becomes physics, we call that physical chemistry. So thermodynamics, energy, electrochemistry, those are components of physical chemistry, where biochemistry, biological chemistry, is where chemistry starts to turn into biology. So these are studies of biochemical reactions, microbiology, things like cellular respiration or photosynthesis, genetics. Those are all things that are part of biochemistry, where we study chemistry in order to understand biology. Another one is analytical chemistry. It deals with the studying of chemical compounds. What's it made of? So this is something where we start to apply chemistry to medicines, to quality of water, diagnosing disease, and also things like CSI. If you were looking to find out like what kind of a material is this particular thing made of, if you've ever watched a show like NCIS, Abby does analytical chemistry. So you would look at a particular material and you would try to figure out what is it? Okay, what kind of plastic, what kind of fiber, what kind of car was it from? Those are all analytical chemistry. You'll notice that in our list, one of this list is not included in our infographic. Which one is it? Good. So theoretical chemistry is not included in these 5 branches of chemistry because these are the 5 classical branches of chemistry, and theoretical chemistry is not classical, it's new. Theoretical chemistry requires using computers to simulate and predict how a chemical might behave. The advantage to theoretical chemistry is that it allows us to simulate what's going to happen without any of the consequences. You know, you don't want to just start mixing things together because what if they explode? I mean, maybe you think that's good, but you don't want to just start mixing things together. You don't want to just give someone a medication and go, we hope it works, like good luck, you know. Instead, we can use theoretical chemistry to predict, are there going to be interactions for this medication? Is it going to bind to the proper component of the cell? We are living in the COVID-19 world right now, and we know that our biochemists, our analytical chemists, our theoretical chemists, our organic chemists, they are all working together right now, along with our biologists, to create not only a vaccine for COVID-19, but also to create treatments to synthesize antibodies to help our bodies be able to better fight the COVID-19 so that we can all come back to school. So all of these branches are currently working together. All of these branches, the thing they have in common is that they work with chemicals. A chemical is any substance with a definite composition and structure. Things like water, sugar, carbon dioxide, those are all chemicals. There are obviously much more complicated chemicals out there, but one of the things we need to start accepting is that in chemistry, we're working with chemicals and that those chemicals are not necessarily bad. Some chemicals are good. They're great. Water is so important. One of my students one time told me when Wendy's first opened, they came over and they said, Mrs. Wally, do you know that a Frosty has more than 20 chemicals in it? Now, I'm not telling you that Frosties are necessarily healthy, but I will tell you that sugar and water are both chemicals, and so is lactose, which is in milk, and there's a whole bunch of other proteins that are in milk. If you wanted to really look, all food should have at least 20 chemicals in it. Chemicals are not necessarily bad, right? So that kind of information that I'm getting from my students, I need to learn to analyze that as a chemist and go, whoa, I appreciate that a Frosty maybe is not made with all natural ingredients, but being made with chemicals, that's not necessarily bad, right? Chemicals can be good or bad, and we need to recognize that. Okay, so within each branch, research chemistry can be done as pure chemistry, as basic chemistry. This is the pursuit of chemistry for its own sake. We're just doing chemistry for no immediate or practical use. I was listening to a great podcast. You guys are going to learn this about me. I love to listen to podcasts. I was listening to a great podcast about a chemist who was just studying when waves crash and that those waves contain bacteria and viruses that get aerosolized into the air and they form these little microspheres, and that changes the chemical composition on Earth. She was just studying that because she studies the ocean and she studies chemistry, and she happened to be studying it. And then, bam, COVID-19, right? And we start talking about the viruses and the microspheres of viruses going out and whether or not masks block them, which they do, and whether or not it helps to wear a mask, which it does. And her pure chemistry, her study of science, immediately gets applied, and we're going to talk about that in a second, immediately gets applied to a practical application. So when she was doing pure chemistry before March 16th, and we all went home for COVID-19, after March 16th, her study was now applied. It was research directed toward a practical goal or application. She was trying to use what she had learned doing her pure chemistry before to enhance, to develop, to apply that to a problem that we were seeing in the environment in front of us. So sometimes chemistry is basic, it's pure, and sometimes it's applied. But either way, it hopefully leads to some sort of technological development. We want products that improve our quality of life, provide more necessities like food, allow us to do things with less effort, reduce our energy, reduce our time, protect the environment, expand our knowledge of the universe. Both pure chemistry and applied chemistry can result in a technological development for us and increasing our quality of life by hopefully decreasing our impact on the environment at the same time. Okay, so within each branch, we're going to see these kinds of studies. So you might be wondering, why do we study chemistry? We can study chemistry for all sorts of reasons. Some people, like myself, come to chemistry because they want to be able to explain the natural world. When you cut up an apple and you take it to school with you and it turns brown, why? And when you put lemon juice on that apple instead, you squeeze a lemon on it and you rub it around in the apple, and then you take the apple to school with you, it doesn't turn brown that day. Why not? Okay, if you want to dissolve sugar in water, if you want to make simple syrup, and you start dissolving sugar, how can you get more? How can you get enough? You want to put 1 cup of sugar in 1 cup of water. How could you do that? That's part of explaining the natural world. What do you do if your car battery leaks acid on your driveway? This is a real problem. I remember being in college and my boyfriend at the time, my husband now, his car battery broke and there was battery acid running down the street. And I knew exactly what to do. You go grab some baking soda, you pour it on the battery acid, you neutralize that battery acid. You could just wash it right down the sewer. Why? Okay, that's what we're learning in chemistry. You could be preparing for a career. This is a way for you to work smarter and not harder. Okay, that's always good, right? We want to be really efficient with our time and energy. But most importantly, no matter whether or not you're interested in explaining the natural world, whether or not you want to be just smarter than your friends, whether or not you want to use chemistry to prepare for a career, you guys are going to vote. You're going to vote on global warming, on whether or not GMOs should be allowed, on you're going to have to weigh cost, benefit. If we use more genetically modified organisms, we can have more food for people, but maybe that food is less healthy for them. Which one do we do? Do you keep your EPA regulations? Do we use more hybrid cars? What do we do with the batteries after those hybrid cars are done? What do we do with them? What research do we fund? Do we cure cancer or do we explore new planets? We have to answer those questions. We, you and I, as citizens, we need to answer those questions. So part of chemistry is just becoming a better, more informed global citizen. For your last question today, I just want you to put down any comment, question, thought. No answer is not an option. So make sure you write something to me about something you learned, what you think is interesting, something you have a further question about. All right. And I will see you guys tomorrow and we'll talk about how this went for you. All right. Have a good day, guys.